My friends, look up at the night sky. For millennia, humanity has gazed at those twinkling points of light and wondered, are we alone? Is our Earth, this vibrant blue marble, unique in the cosmic ocean? Today we stand at a thrilling frontier, armed with telescopes that are veritable time machines and planet hunters. We're discovering that the universe is far more generous with its real estate than we ever dared to imagine. We're finding worlds orbiting other stars' exoplanets. And among them, some whisper of familiarity. Planets that bear an uncanny resemblance to our own home. Potential Earths scattered across the cosmic tapestry. The quest to find these Earth-like exoplanets is more than just an astronomical endeavor, it's a profound human journey. It speaks to our deepest curiosities about our place in the universe and the potential for life beyond our own world. We're peering across unfathomable distances, sifting through the light of distant suns for the subtle telltale signs of planets that might harbor the conditions for life. Planets nestled within the habitable zones of their stars, where liquid water, that essential ingredient for life as we know it, could exist. This search is a testament to our relentless drive to explore, to understand, and to connect with the cosmos. Join me as we embark on an exploration of these cosmic twins, these other Earths. We'll journey to distant star systems, meet worlds that challenge our imagination, and ponder the profound implications of their discovery. The universe is beckoning, and its secrets are slowly, tantalizingly, being unveiled. What will we find out there? The possibilities are as vast as space itself. Let's venture forth. Our first stop takes us to a star system some 1,400 light-years away, in the constellation Cygnus. Here, orbiting a star remarkably similar to our own sun, we find Kepler 452b. This exoplanet has earned the endearing moniker Earth's cousin, and for good reason. Its host star is a G-type star just like our sun, meaning Kepler 452b basks in a similar quality of light. Imagine standing on its surface. The sunlight filtering through its atmosphere might feel strangely familiar, a distant echo of a terrestrial afternoon. It orbits its star at a distance that places it squarely within the habitable zone, that precious region where temperatures could allow liquid water to pool on its surface, forming lakes, rivers, perhaps even oceans. This similarity in stellar parentage and orbital position makes it a compelling candidate in our search. But Kepler 452b is not an identical twin. It's what we call a super-Earth, estimated to be about 60% larger in diameter than our planet, and with a mass potentially 5 times that of Earth. This greater size means it likely has a stronger gravitational pull. What would that feel like? How would it shape the geology, the atmosphere, even potential life forms? Furthermore, Kepler 452b is older than Earth, having spent an estimated 6 billion years in its star's habitable zone. That's 1.5 billion years longer than Earth has existed. Think of the immense timescale for geological processes to unfold, for an atmosphere to mature, and, if the conditions were right, for life to potentially arise and evolve in ways we can only begin to speculate about. The discovery of Kepler 452b, made by NASA's Kepler Space Telescope, was a landmark moment. It showed us that planets not much larger than Earth, orbiting sun-like stars in the habitable zone, are not just a figment of our cosmic imagination. They are out there. While we cannot yet see Kepler 452b directly in detail, it's simply too far away for our current instruments to resolve surface features. Its existence fuels our optimism. It tells us that the ingredients and conditions that made Earth a haven for life might not be so rare after all. Each such discovery is a stepping stone, bringing us closer to understanding just how crowded or how lonely our galaxy might be. Now let's journey to another fascinating system, this one about 500 light-years away, home to Kepler 186f. What makes this world particularly exciting is its size. Kepler 186f is the first Earth-sized planet discovered orbiting within the habitable zone of another star. It's less than 10% larger than Earth, making it a much closer analog in terms of sheer physical dimension than many other super-Earths we've found. This similarity in size is crucial because it suggests that Kepler 186f could be a rocky, terrestrial planet much like Earth, Mars, or Venus, rather than a gaseous giant like Jupiter or Neptune. Imagine a world with mountains, valleys, and perhaps even continents all roughly on the same scale as our own. Kepler 186f orbits a star significantly different from our Sun. Its parent star is an M-dwarf, a red dwarf star, much cooler and dimmer than our Sun. This means its habitable zone is much closer to the star. Kepler 186f completes an orbit in just 130 Earth days. Because it's at the outer edge of this habitable zone, it receives less energy from its star than Earth does from the Sun, comparable to the amount of light Mars receives. This has led some to describe it as an Earth twin in the twilight zone. If it has an atmosphere capable of trapping heat, a greenhouse effect, then liquid water could very well exist on its surface. The color of the light would be different too, a perpetual ruddy twilight compared to our bright sunshine. The potential for liquid water on Kepler 186f is a tantalizing prospect. Water is the solvent for life as we understand it, the medium in which the complex chemistry of biology unfolds. While we don't know for sure if water exists there, or if the atmospheric conditions are suitable, its size and location make it a prime candidate for further study. Planets orbiting M-dwarf stars are incredibly common in our galaxy, so understanding the habitability of worlds like Kepler 186f is key to estimating the prevalence of life elsewhere. Could life thrive under the dim red glow of an M-dwarf? Kepler 186f offers us a chance to ponder this very question, pushing the boundaries of what we consider habitable. Imagine stepping outside our solar system just a little way, cosmically speaking. Our very nearest stellar neighbor, Proxima Centauri, a faint red dwarf star only 4.24 light-years away, harbors a secret, an exoplanet named Proxima Centauri b. This isn't just any exoplanet, it's the closest known exoplanet to Earth. Think about that for a moment. For all of human history, the stars were distant, unreachable points. Now we know that a whole other world, potentially rocky and roughly Earth mass, orbits the very next star over. It's like finding out there's an uncharted island just beyond your own shoreline, a place you could perhaps one day visit. Proxima b orbits its red dwarf star in a mere 11.2 Earth days, placing it well within Proxima Centauri's habitable zone. Despite this close orbit, because Proxima Centauri is so much cooler and dimmer than our Sun, the planet receives an amount of energy that could allow for liquid water, provided it has a suitable atmosphere. Its discovery ignited a firestorm of excitement, not just for its potential habitability but for its proximity. It's a prime target for future interstellar missions like the ambitious Breakthrough Starshot initiative, which aims to send tiny light sail-propelled nanocraft to the Alpha Centauri system, of which Proxima Centauri is part, within a generation. We could conceivably get our first close-up images of an exoplanet within our lifetimes. However, life around a red dwarf like Proxima Centauri faces significant challenges. These stars are known for powerful stellar flares, eruptions of intense radiation that could strip away a planet's atmosphere or bathe its surface in harmful rays. Proxima b is also likely tidally locked, meaning one side perpetually faces its star while the other is locked in eternal darkness. This could create extreme temperature differences, yet a thick enough atmosphere could potentially redistribute heat, and a strong magnetic field could offer protection from flares. The study of Proxima b is a fascinating exercise in planetary science, forcing us to consider how life might adapt to conditions vastly different from those on Earth. It's our cosmic next-door neighbor, and it beckons us to learn more. Prepare yourselves for something truly extraordinary. We now travel approximately 40 light-years away to the TRAPPIST-1 system. This isn't just about one potentially habitable planet, it's about an entire system teeming with Earth-sized worlds. The star, TRAPPIST-1, is an ultra-cool dwarf star, even smaller and dimmer than Proxima Centauri. And around this tiny star, astronomers have discovered no fewer than 7 rocky planets, all comparable in size to Earth or Venus. It's like finding a miniature solar system, a compact family of terrestrial worlds unlike anything we've seen before. Imagine looking up from the surface of one of these planets and seeing several other large nearby worlds gracing your sky. Among these 7 siblings, at least 3, TRAPPIST, 1-day, E and F, are believed to orbit within the star's habitable zone. Today we focus on TRAPPIST-1d. It's slightly larger than Mars, but less dense than Earth, suggesting it could possess a significant amount of water, perhaps in the form of a global ocean, or as thick ice layers, or even a dense, steamy atmosphere. Its position within the system means it receives a moderate amount of stellar radiation, potentially allowing for surface temperatures conducive to liquid water, depending on its atmospheric composition. The close proximity of these planets to each other also means they exert significant gravitational influences, which could lead to tidal heating, another potential source of energy for life. The TRAPPIST-1 system is a natural laboratory for studying planet formation and the potential for habitability around very low-mass stars. Because the star is so small, the planet's transit pass in front of the star from our perspective more frequently and cause deeper dips in starlight, making their atmospheres easier to study with telescopes like the James Webb Space Telescope. We have the potential to search for biosignatures, chemical fingerprints of life, in the atmospheres of these worlds. The discovery of this remarkable system, with its multiple Earth-sized planets in or near the habitable zone, has electrified the search for life, offering us so many targets in one convenient, albeit distant, location. It's a truly stunning cosmic configuration. Our final destination for today is the Gliese 667 system, a captivating triple-star system located about 23.6 light-years from Earth. Within this complex stellar neighborhood orbits Gliese 667 cc, a planet that falls into the category of super-Earth. It's estimated to be at least 3.8 times the mass of Earth, possibly more, and orbits its M-dwarf parent star, Gliese 667c, well within the habitable zone. This star, Gliese 667c, is itself part of a wider binary pair with two other K-type stars, Gliese 667a and Gliese 667b. Imagine the night sky from Gliese 667cc. It would be a truly spectacular sight, with potentially 3 suns of varying brightness and color, depending on their positions. Gliese 667cc receives about 90% of the light that Earth gets from our Sun. This is a very promising amount of stellar energy, suggesting that if the planet has an atmosphere capable of retaining heat, surface temperatures could be quite comfortable for liquid water to exist. Its status as a super-Earth means it likely has a stronger gravitational pull than our planet. This could lead to a thicker atmosphere which might offer better protection from cosmic rays and help regulate surface temperatures more effectively, crucial for habitability, especially around M-dwarf stars which can be prone to flaring, though Gliese 667c is a relatively quiet M-dwarf. The presence of multiple planets within the habitable zone of Gliese 667c, others have been suggested though CC is the most robustly confirmed, makes this system particularly intriguing. Super-Earths like Gliese 667cc represent a common type of planet in our galaxy, perhaps even more common than Earth-sized planets. Understanding their potential for habitability is therefore a critical piece of the puzzle in our search for life. Are these larger rocky worlds better at holding on to atmospheres and oceans? Could they foster different, perhaps even more diverse forms of life than smaller planets like our own? Gliese 667cc stands as a compelling example, urging us to expand our definition of what a habitable world might look like. What an incredible journey we've shared, traversing light years to visit just a handful of the thousands of exoplanets now known to us. From the older, larger cousin Kepler 452b to our nearest neighbor Proxima b, and the intriguing systems of TRAPPIST-1 and Gliese 667, each discovery paints a richer, more complex picture of our galactic neighborhood. The universe, it seems, is brimming with worlds, many of which challenge our preconceptions and expand our understanding of what's possible. The sheer excitement of finding planets that share characteristics with our own Earth, worlds that might hold the potential for liquid water, perhaps even life, is a profound motivator for science. I encourage you to take a moment to let your imagination wander across these cosmic distances. Picture yourself standing on the surface of Kepler 186f, under the dim red glow of its sun, wondering if water flows in hidden valleys. Imagine the sky above TRAPPIST-1d, crowded with sibling worlds. What would it be like to experience the stronger gravity of a super-Earth like Gliese 667cc? What forms might life take if it has arisen in these alien environments, sculpted by different suns, different chemistries, different histories? These are no longer questions confined to science fiction. They are the very questions driving scientific inquiry today. The search for Earth's cosmic twins is, in essence, a search for ourselves, for our context in the grand scheme of things. Each new world discovered is another data point, another piece of the puzzle. We are explorers on the shores of a vast cosmic ocean, and the waves are just beginning to lap at our feet, bringing tales of distant lands. The adventure is far from over, it is, in many ways, just beginning. Keep looking up, keep wondering. The universe has so much more to show us.